Okay, some of the aspects that we spent some time on in this chapter is an isomer. Okay, so that's probably going to be on your vocab quiz that you have tomorrow. Okay, so someone give me a number between 5 and 9. Okay. So then how many, if this is an alkane, okay, so it would have 14 in there. Okay, so if we start with this compound, which is what? What C6H14 is what? It's hexane, okay? So here is our parent chain. So what is the difference between what's written in green and what's written in brown? Well, which one's which? Okay. Is there a glare on the board? Okay, well, let's try this. Here come the lights. I bet that's better, right? Okay. So the one on the left in brown is what type of formula? Molecular formula. So the green one, or the one on the right, is what? The structural formula. Okay. So what is the simplest way to make an isomer of hexane? The simplest thing you can do. Something about a methyl group. What would that be? Say that again. Okay. So said place a methyl on a separate carbon. You said a different carbon. The second, well, I did. Here's the second one right here. 1, 2, that's the second one. No? Okay. Maybe do what with this guy here? Okay? So, what is our molecular formula for that compound? Okay? So, it still has that same formula, but it's a different what? Different structure. Is there another isomer we could do? Yeah. What's the next easiest thing you could do? Okay? How many more? Keep going. Another one, right? Okay. I forgot a dash. Oh, okay. So we see a pattern. We're starting on the right side and moving left. Okay? Well, common sense would tell us let's just keep moving over one more. You can't. Who does not visualize that that does not work? In other words, if we say this, okay, why does this not work? We said just move it over another one. It's the same thing as which one? This one. Because this is called 2-methyl what? 2-methylpentane. What's this one called? 2-methylpentane. This one is 3-methyl. Okay? Are we catching on to what isomers are? Once you get these lights warmed up, it really brightens it up in here. Okay? Yeah, we're just not used to it. Agreed. Do you think there's another isomer we could do? Okay? You know what that reminds me of is Secret Service agent. Usually, well, I mean, that's fine. Maybe that's more important. Liberty is on the move. Who's Liberty? It's a code word. Or eagle is moving. Yeah, it's the president. That's a code word for the president. Whether it's Liberty or Eagle or something to that effect, because you're communicating with your other Secret Service agents that the president is on the move. All right. So someone had mentioned an ethyl group. Well, let's go ahead and try that. This is the funny thing about isomers. Sometimes you can't really do anything until you actually write it down. If you try to visualize that in your head. Is that an isomer? No, it is not. That's what I mean. Unless you are very, very good at analyzing, visualizing things in your head, okay, that is not an isomer. What is the name of that compound we just wrote down, do you think? Okay, what we need to do is find the longest continuous chain, right? 1, 2, 3, 4. You say 5. Okay, well, 1, 2, 3, 4, 5. In other words, if this branches like it does, rather than this straight chain, okay, this methyl group right here is branching off of which one? The third one. What's this one doing? Branching off the third one. These are the same compounds. Okay. Is anyone confused with that? Left outside. Are we on the bus? Left middle. Middle. Right middle. Right outside. Okay? So, and the reason we're going over these, we're starting to do this for general chemistry. You'll notice, what do those look like in the upper right-hand corner? What do these look like to you? Yeah, those are the derivatives. We're starting that with the general chemistry students, except for there's actually one more down here that we have to go over. Okay, so we take this in a nice, slow, progressive fashion. In other words, you need to know 2 derivatives at this level. When you get to be juniors, then you need to know 4. And then if you really like this stuff and take it as seniors, then you need to know 8 of them. Okay, so that's why thrust all them into say one big package. I think that's a little overwhelming, unless you say, gosh, we need to know more of this. No? Is 2 enough? Is 8 too many? Oh, I think you're capable. Who thinks we're capable? Well, how do you know until you try it? Like, just think, some of you golfers, how do you know whether you like golf until you try it? Well, I don't want to wear those silly looking pants and hats. Is that what you're thinking? Do golfers wear silly pants and caps? Sometimes they do. Yeah. All right. Regardless, okay, one of the things, what about if you put 2 methyl groups on there? Okay, well, let's try it. And, okay. Now, if we do that, we can't add carbons to this. Does anyone see a problem with that? Oops, I meant to do that. Does anyone see a problem with this? There's what? Yeah, there's too many carbons. There's 7 up there. We can't have 7. We have to have 6. Okay, so we can't do this. All right. Well, okay, now we still have the same as this one, But what we could do, well, how about we take this guy off the end and maybe put him, oh, I don't know, how about right here? If you had to name this, what's your parent chain called? Okay, you're doing the hard part first, which is fine. I mean, you're already at the end, and maybe myself and everyone else is still trying to catch up, which is okay. So what's the parent chain called? Okay, so butane, and we got two methyl groups branching off of that butane, and where are they located? On the second one. So we don't just say 2, we gotta say 2 comma, and I ran out of space, 2 comma 2 dimethyl butane. Okay? Then there's actually one more that we could do. But if you had enough of these isomers, okay, fair enough. So regardless, any one of these compounds, they all had the same molecular formula. It was all C6H14. Okay, so from yesterday, we had this compound. He was up, this one was down. Okay. How many of you looking at that would have no idea where to start? Okay, so what is different about this compound than the prior ones that we were discussing? This still has how many carbons in it? Still has 6 carbons in it. 1, 2, 3, 4, 5, 6. But how many hydrogens does it have? Not 13, unless I drew it incorrect. Huh? Do we agree with 12? Do we agree with 12? Well, that answers that question. Okay, fair enough. So, what type of organic family do we have? Because we've already established that it's different. For one, we took 2 hydrogens off of there. So it is no longer what organic family? It's no longer an alkane. Now it is a what? Alkene. Okay? So does the prefix for alkenes change from alkanes? How? Okay, prior it was this, correct? Okay, so how is this name going to change from this to whatever this compound is? Okay, is now, because you correctly said it's an alkene. Okay, so we have to account for 2 things on that parent chain. What would they be? Because is there anything branching off of that chain? Yes, there is. There's a methyl group. And when we establish that this is an alkene, that means somewhere in that compound there is a what? There's a double bond. Okay? So when that happens, okay, that's why we're spending so much time on this. We could just say, write this down and give you the paper and say, okay, get these done. And would that be okay? I don't really think that's instructing you how to do things, but it's what could be done. I don't think that's fair, but so let's just keep plugging here. So the double bond has to have the lowest number. Okay, that's what takes priority here. Okay, so we could just say when you have daily classes, physical science takes priority. It probably doesn't, but we're going to say it does. It does, right? Yeah. It does, right? Yeah. You can say it does, right? It does. It does. Yeah. It does. It does. Oh, shoot, I'm only 1 for 6 so far. Okay. So, anyway. So with that, so if that is the case, if this takes priority, which it does, which way are we going to number these? Left to right or right to left? Left to right. Okay? Because if this takes priority, which it does, if we were to go this way, that number would be what? It would be 3. It would be greater. But if we go this way, it's 2 instead. Okay? So where is our lone derivative located on which carbon? So if you establish we're going this way, it's on 3. Okay? This one's on 2. You ever done a junior high football play where the snap count was on 3? Because everyone always expects it's on 1 or 2, right? So, well, let's try running a play on 3. And it worked. They jumped off sides. They thought it was on 2. So don't guess, right? Sometimes what's funny in football, it's the nose tackle that jumps off sides. And you got to be thinking, how's that even possible? The ball is right in front of you. Unless you just want to flinch or you see some sort of movement. But anyway. Okay. So name the derivative first. Okay, which you would have correctly said it's on carbon 3. Okay, so 3 dash what? Methyl. Okay. And then you have to say where that double bond is, which is after which carbon. 2. Now, when we do this, okay, remember, if we're not writing anything after a number, it's just telling you where that organic family is or where that multiple bond is. We can make sense of that by discussing what we did yesterday. In other words, if we had this, okay, this tells you the organic family, which it is a what? It's an alcohol. Okay, so what's the parent chain? But where is that, the hydroxy or alcohol located? It's on the 2. Okay, so when there's nothing written after the number, it's telling you where the organic family is, okay, or where that double bond or triple bond is. This is a big step combining what we learned yesterday into today. Okay? So if we reverse engineer this, what is this ENE telling you? That there's a double bond. Okay? What is HEX telling you? There's 6 carbons. Okay? What is this? What's the significance of this 2? It's referring to where that double bond is, because there's nothing written after. It's just a dash. Okay? So then this says there's a methyl group, and where's that methyl group located? On the 3rd carbon. Okay? So is it worth our time to show you how we reverse engineer this to see where the compound came from? Or is it, I really don't understand it one way or the other, or yes, it's worth our time to do this. Okay, this big intuitive leap we just made with that double bond. Left outside, are we on the bus? Left middle, middle, right middle, right outside. Okay. So again, I can't stress that enough. At the very end, look to see what organic family you're dealing with. This tells you have an alcohol. Okay? This says you've got 4 carbons. There they are. There's nothing written after that 2, so it's pertaining to your organic family. Okay? This is telling us our organic family, that double bond. This is saying how many carbons there are. There's nothing written after this 2, so it's referring to this. And then finally, this says there's a methyl group on the 3rd carbon. Okay? Can we erase this? Okay. This class goes by way too fast, even though that's not the bell to be dismissed. We're not going to say that old adage when you think about time going fast, because maybe we do or don't believe it. That's fine. Okay. Okay, so we did a really hard one just prior to this. This one's quite a bit simpler. Okay, would you believe that? This is quite a bit simpler. Okay, so the first thing you need to establish, you look at this. Okay, what do we notice? There's 7 carbons, so right away we know what is the prefix for anything with 7 carbons. Okay. Okay. Now, what type of organic family are we dealing with? It's an alkene. All right. So we know because of this, and that there's 7 carbons, we can logically say that we've got heptene. Okay. We're not quite done yet. There's only one thing left that you have to do. And that is what? You need to establish or say where that double bond is. So what do you think? Is it 3 or 4? 3. In case you're wondering where these numbers come from. If we go right to left, that double bond is after which carbon? The 4th one. But if we go left to right, it's after the 3rd one. So, and again, box. What's this telling you? The organic family. It's an alkene. What is this telling you? That there's 7 of them in the parent chain. There's nothing written after this 3. So, that must be referring to what? It's telling you where the double bond is. All right. So, could you make an isomer of this structure? Yes, sure you could. Just like your prior example with the alkanes. The very simplest thing to do would be doing what with that double bond? Okay? So, and let's go ahead and do that. So we're going to remove that double bond. And we're going to put a single bond there. We're going to put a double bond here. And remove him there. 1 isomer down. It can't be. I moved it. It's still after the 3rd carbon, isn't it? Okay. So one of the reasons we put these, I'll call them trap doors, whatever, is let's establish them together as a group. And if it's a mistake, again, what do we talk about with mistakes? 2 things. Try not to repeat them and learn from them. Okay? When you go off to tech school or your job or the military or to college, you're going to make mistakes. Okay? It's going to happen. So that's why we say let's try to learn from them. Okay, so the double bond was here. What's the simplest thing we could do? You said move it. We can't go right, but we can certainly do what? We can go left, put them here, and then take off some hydrogens. Why do we have to do that? How many bonds does this carbon have? 1, 2, 3, 4, 5. This one's got 1, 2, 3, 4, 5. Do we understand why you got to take a hydrogen out? Left outside. Left middle. Middle. Right middle. Right outside. If we keep nodding, you're telling me that you understand, and that's what you're saying, okay? So let's do this and this. So we don't have 3-heptene anymore. What do we have? 2. Just 2-heptene. Okay? The double bond was here. We moved it 1 to the left. Went from 3 down to 2. Okay? As far as double bonds are concerned, is there another isomer we could do? Yes. Do what with the double bond again? Move it. Okay? How many of you are thinking, whoa, 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 how did you get way over on that side? Magic. I like that. So what do we have now? We just have heptene. But if you really, really wanted to be specific, what would you do? But you don't have to put that 1 there. You can. I mean, there's nothing wrong with that, but it just might look a little silly. Okay. Are we good with alkenes, do you think? Left middle, or excuse me, left outside, left middle, middle, right outside, right outside. You skipped the right middle. You thought I forgot. Maybe, maybe not. Okay. What is that besides a triangle? So how many carbons are in this shape? Okay, there's a carbon atom there, and there, and there. So there's 3 carbons. So we've got propane. But we got to be a little more specific than that, because this is a ring structure, so it's cyclo. Okay. And then we could do the same thing. What do we have here? Okay. Now we've got a substituted hydrocarbon because we've taken a hydrogen off and placed a what on there? A chlorine group. Okay? So we name that first. Okay? Since there's only 1 chlorine on there, it just means you can put a 1 there, but you don't have to because there is only 1. Okay? Okay, and then this is a fairly difficult one. Okay? Look at your organic family. What is the organic family of that compound? It's an acid. Okay? So how many carbons are in this compound of this organic acid? But how many are in the parent chain? Yeah, there's 8. There's actually 6. Okay. Can this be written differently? Yeah. What type of group is this? Yeah, it's actually an ethyl group. So maybe what we could do, C2H5. Okay. Now, this might be a little tricky in saying, well, we get 6 going this way, we get 6 going this way as well. But why can't this branch like that? Because we've already established what type of organic compound is this. It's an acid, so this has to be part of the parent chain. Another big intuitive leap. Left outside. Left middle, understand, middle, right middle, right outside. Okay? So, we've established that this is an acid. Okay? What is the number of carbons in this acid? There's 8, but in the parent chain there's only 6. So what's the prefix for 6? Okay. And what else do we have to illustrate? Okay. So this has to be number 1. There's number 2. And on our third carbon, we've got what? Okay. 3-ethyl hexanoic acid. Again, we can reverse engineer this. This is telling you the organic family. So somewhere on the first carbon, there has to be what? A double bonded oxygen and hydroxy group, or OH. Okay? What is HEXAN telling you? That there's 6 carbons. There they are. What is an ethyl group? C2, H3 and 2 is 5. And where's that ethyl group located? On the third carbon. There it is. Okay. That's probably enough for today. I would agree. So before we go any further, left outside. Are we on the bus so far? Left middle. Right outside. Right middle. And middle. All right. So we have a paper to hand out to you for Friday. And don't forget, tomorrow you have a vocab quiz. And if you have any problems with these compounds, who feels we really have a good understanding of this? For those of you who don't, see those people with their hands up? You can go ask them if you choose to. Or you can come in here and talk to myself. We'll catch up to you next time.